Good morning, students. I hope you all are well and doing mathematics comfortably. These days, we people are doing abstract algebra and we are doing elementary properties of a group. You people know that group is a pair in which a set with binary composition be included, and this set must be non-empty, and this is binary operation. We have discussed several properties of a group. Today we will discuss one more property, and that is also important in the point of university examination or competitive examination. So let us continue. In a group, if A square equals to E, where A square means then J is abelian. Several times I told, go through the problem or paragraph, whatever it is given, very carefully. Find out what is given and what is to be proved. It is very important. Go through word to word and analyze. In a group means the group is given, non-empty set is Z and binary composition is denoted by this one. If A square equals to E, in a group this part is given, A square equals C. And what is the meaning of A square? Here it is written, A square means A is composed with itself. If composition is plus, then A plus A. Multiplication, that is A into A, and so on. If the composition is union, then A union A. So it is like that. So A square means this. Always remember, this composition is not necessary that the multiplication. मैं बार बार आपको रिपीट करता हूँ, ये composition जिसको स्टार से डिनोट किया है, ये जरूरी नहीं कि मल्टीप्लिकेशन हो, ये कोई भी बाइनरी कंपोजिशन हो सकता है. So it is A star A and A belongs to Z. Definitely. Then prove that J is abelian. Abelian means A star B equals B star A. This we have to prove. So let us see. This we consider as a theorem. प्रमेय जिसको बोलते हैं. It is this. The proof. J is a group. Okay, so let's A comma B belongs to C. Always remember, we have to prove J is abelian. So we will show A asterisk B equals B asterisk A. So I took any two elements, that is A, B belongs to Z. That's A comma B belongs to Z. Therefore, these two elements are in J. Therefore, their composition is also in J. Because this is the binary composition in Z by definition. Again, we are given a square equals to e. This part is given if a square equals to e. Therefore, b square is also e. And a star b is also e. A square equals to a means the element of z, whatever it is, कैसा भी element हो, when we square it, then the answer must be, this is given to us. A square means a is composed with a. Always remember, a comma b belongs to z, so this is the element. Let us suppose this k, for example. If k belongs to z, then k square is equal to e because it is given to us. So, we people are given a square equals to e. In the similar way, therefore b square is also e. A square b is whole square is e, etc. Now, a square equals to e. Therefore, what is the meaning of a square? It means this. On pre-operating by a dash or where is the inverse of a. Pre-operating means पहले. This is one side, this is the side. किससे ऑपरेट किया? A इनवर्स से. Since G is a group, A belongs to Z, therefore inverse exists. So where A inverse is the inverse of A. इससे ऑपरेट कर रहे हैं. Therefore, this is. Always remember, when we operate, we write the symbol of binary composition. This is left hand side, this is right hand side. Equation के दोनों तरफ. Continue from this side. Equals by AL एसोसिएटिव लॉ, साहचर्य का नियम. कहाँ अप्लाई किया मैंने? इसके अंदर. ये what is the answer of this? E by definition. This is any element composed with the identity element. The answer is the element. The answer is the element itself. So here A is the identity element of the binary composition in Z. Okay, so here is identity. This is A equals to A inverse. Therefore, if A square equals to E, then A inverse is A. Very important. Sometimes it is asked in competitive examination, or this may be asked in this way. In a group Z, if A square equals to E, then prove that A inverse equals to A. In other words, दूसरे शब्दों में क्या बोलोगे? एलिमेंट एंड इट्स इनवर्स both are equal. So in other words, if a square equals to a, then every element is inverse of itself. प्रत्येक अवयव स्वयं का प्रतिलोम है. एवरी एलिमेंट इज इनवर्स ऑफ इटसेल्फ. दैट मीन्स वेरी इंपॉर्टेंट स्टेटमेंट, ध्यान रखना है. इस थ्योरम को हम ऐसे भी बोल सकते हैं, इफ एवरी एलिमेंट इज इनवर्स ऑफ इटसेल्फ, if every element is inverse of itself, that means this one, then prove that the group is abelian. So sometimes it is asked like this, इस तरह से पूछा जाता है, यदि प्रत्येक अवयव स्वयं का प्रतिलोम हो तो सिद्ध करो कि दिया गया समूह आबेलिक समूह होगा. ये मैंने इसका हिंदी अनुवाद किया है. ओके, सो दिस इज द वन पार्ट ऑफ दिस वन. So we have proved therefore if a square equals to a, then a equals a. Similarly, b square equals to e implies b equals to b inverse. Implies etc. A square equals to e, that means this. Instead of a, if this is the element, then this one. If this one, we have already seen this is also the member of Z, so the square of this is a, it means it is equal to this one. Now, a as this b equals, this is कौन सी प्रॉपर्टी? याद करो, बाय रिवर्सल लॉ वी हैव डन. The property is connected with some other property also. That's why we are saying this property first. This property is used here to prove this one. So there is a sequence. So here it is. And what is B inverse? B inverse is B. What is A inverse? Is A. Therefore, A as this B equals B as this A. Therefore, Z is abelian. An abelian group. The proper proposition. Okay, so how to prove this? A square is E. This is given to us. It means A equals A inverse. ये sufficient है. इसी से हमें क्लू मिल रहा है. If A equals A inverse, then we took A star B is A star B inverse. Then use the reversal law and the theorem is completed. So this theorem may be asked in other words, alternative statements, alternative statement, in a group C, if every element is inverse of itself, then Z is an abelian group. The alternative statement of this are, in a group Z, if every element is inverse of itself, then Z is an abelian group. So what is given here? Every element is inverse of itself, means A equals A inverse. This is given. This is given to us. So we begin with this, then we prove as usual. Okay, so sometimes instead of A square equals to E, it will be given this. Every element is inverse of itself, then Z is an abelian group. Okay, so this is very important. Now we come to the next problem. You try to prove yourself. मैंने किया है ये, आपको समझ में आया होगा. I hope you have understood. But you do yourself. First, you try to understand what I have explained. Then close the video, pause the video, just pick up pen or pencil and notebook and try to do yourself. This is the best way to practice. Come to the next. In a group Z, where is the inverse of it. Inverse of inverse is the identity. Inverse of the inverse is the element itself. This we have done in matrix also in class 12, if you remember. In set theory also, complements of a complement is the set itself. In set theory. This is in matrices. In the similar way, it is in a group. We will prove this. In a group, inverse of the inverse is the element itself. Okay, so let us say let's A belongs to C. Therefore, since J is a group, again identity. A inverse star A is identity element. Definitely. क्यों लिखा है? क्योंकि मुझे ये वाला पार्ट चाहिए. So if I multiply or if I compose, not multiply, compose binary operation with this one, then the element itself. Okay, so A and its inverse Bhim Duryodhan, then identity element is obtained. So again on pre-operating by on pre-operating both the sides by this one. So this is left side, this is right side. Either pre or post. See the situation, okay? So let us see. As this A equals any element operated with the identity element, the answer is the element itself, and here we apply the associative law. So this is by KL. Remember, it is not Amrit law, this is associative law, okay? Look at this. This is the element, the same one you can see. It looks like K. This is K inverse. Element is composed with its inverse, then the answer is E. So here this is E, as this A equals, it will be this. This is A, henceforth. Okay, so this is the way to prove the given theorem. So try to learn how to prove the theorem by going through word to word, find what is given and what is to be proved, and apply the basic concept, practice on it, and find the answer. So I hope you have understood. Thank you very much. Jai Hind.